In this video, I will show how the Asset Compute service can be used, and I will write a custom worker leveraging Sensei magic. First, I have selected a PDF file of some slides, and I'm requesting renditions. The request is in this JSON format, and I'm requesting a PNG thumbnail at 600 by 600 pixels. And on the right-hand side, in this developer tool for invoking the service, you can see a preview of the generated rendition. And if we open it, we see this is an image of the cover page. The second rendition I requested was a text rendition. And so if we click the link, we get a full text of this PDF with the text extracted. That's a plain text file. Now I can show some other files as example. Here's an image. And if I run the same request, we will see it generates the two renditions as well. So it's slowly loading, but first look at the text rendition, which is empty because that's an image that doesn't contain any text. And if you look at the PNG rendition, we will see it was created as well. Now that you have seen the basic functionality of the service, I will write a custom worker. This worker will add a caption to the image. It will ask a Sensei machine intelligence to extract a title prediction for the image, and then we're going to use image magic to actually put that label onto the image and generate a rendition. So in this shell, I'm creating a new folder for my project, and we have a command line application called NUI, which is the project name, that allows us to make some developer steps easier. And one interesting command here is NUI init, which allows to create a basic project based on a template. The template we're going to select is a Sensei template because we're using a Sensei function here as input. So we are calling NUI init Sensei. It creates some files, runs npm install. So we have a working project setup. Now I'm going to open this in Visual Studio Code. And there's basically two files, the worker.js and the package.json. So let's go into the worker.js, which is the actual code. At the top, there's some imports and boilerplate, which we can ignore at this point. But if we look at the main function, which is the entry point for the OpenWhisk action and the entry point for the worker, we see we have some basic scaffolding that was part of the template that uses the NUI module or NUI library that iterates over renditions. And essentially for each rendition, it will give us a source file name and a rendition file name to generate. So the template here calls a Sensei function. What we want to do is call a Sensei function for the title prediction. So that's the first thing, and the name of that Sensei analyzer is title prediction that we have to enter here. This actually makes a call to another action or service and returns the value. Now, in the second step, we're going to have a promise chain here. Since we get back a larger JSON with multiple title predictions and different values, in this case, we just take the first one with the highest value. So this line of code here will select it from that larger JSON. And then in the third step, with that caption as a string available here, we want to call a locally available image magic to add that caption to the image. So we're going to invoke image magic as a command line app here, and I'm pasting in the command. There's actually a tool as part of the image magic suite called montage, and it has a basic command which allows to put a label at the bottom of the image. We pass in the caption, we have the source file and the rendition to generate, also a file name, and then some other settings with background color and font size. And that's it. That's the code. The next step is we're going to switch to the package.json, which describes our project and is also going to be used for the deployment. So the name is important. The name will become the worker name, and we name it image caption. And we can give it a description, which is available as an annotation later. The other settings, what container to use, and so on, are already part of the template. We don't have to worry about it. So we go back to the command line shell. And then here we're going to look at the OpenWhisk namespace where we're going to deploy into and list the existing actions. So we see we got a couple there, but ours is not there yet. We're going to use the NUI command line tool to package and deploy what we just coded. Deployment is done. Let's list the actions again. We see it was pushed to the runtime, Adobe I/O runtime, OpenWhisk environment. And if we list the actions, we can see our new action image caption there at the top. So it has been successfully deployed. Now, with that part done, we switch back to our developer tool for invoking the service. And we are going to request a new third rendition here, where because it's a custom one, we explicitly reference the name of the worker we want to invoke, which is the one we just added, image-caption. And we give the rendition file name a name. The extension JPEG here is then used by ImageMagick to know what format to generate. And then we run the service or the processing again, this time generating 3 renditions. And the last one is our new one. And if we open this, we can see, hey, at the bottom there is a caption, group of friends sitting on a bench in the park, which seems like a fitting description. And now let's show this for a couple other files. So we remove one rendition so we get a little bit quicker result. Here we got a picture of an elephant, and this run is going on. We wait a little bit. And there we have our new rendition. And if we look at it, you can see it labeled it with elephant in Kenya. Perfect. So this is an overview of the code involved. We got the worker.js, which is the actual code we had to write, doing the 3 steps. We have a package.json, which describes our worker and is used for deployment. And we see an example of a resulting image. Thank you for watching.